12. In the previous video, we explained this activity, okay? And we use the law of conservation of energy. You can go back and watch the video. Let's now try to do the same question, but using the work-energy theorem. All right, now, I recommend you to try to do the question alone and then watch the video to mark the question and see whatever you don't understand. So don't just watch the video, how do I solve the problem? Just try to solve the problem. You can stop the video and then check the answer, okay? That is my recommendation. I think it will help. So this question was done. We're just going to do the same question, but using the work-energy theorem. So I'm going to go on with the same solution because we are going to use the same problem. Maybe I need to use a new page. Let me just see quick. Okay, here we are. So we're going to go to option 2. Let me just get a color. Let's go to same option 2. This is just to practice both methods instead of going to other questions. The same work-energy theorem. So we're going to use the work-energy theorem. And before we go to the question, let's just record the work-energy theorem. The work-energy theorem states that the work done by the net force is equal to the change in kinetic energy. Okay, so let's go back to the problem now so we can look at the solution. Let's say a 60 kilogram skier with a mass with its initial speed of 12 meters per second, there is at the bottom, goes up a 2.5 meters high rise as shown in the figure. Find her final speed at the top given that the coefficient of friction between the skier and the snow is 0.08. And then they give you a hint there, which we did explain in the previous video. So the data, the mass of the skier is 60 kilograms. The kinetic coefficient of friction is 0.8. The initial speed of the person here at the bottom is 12 meters per second. The angle of inclination of the incline is 35 degrees and the height is 2.5. You're looking for the speed of the object right here. Now, in the previous video, we did the free body diagram. Is a very important steps. So let's just record what are the forces acting on that person. Well, there is the frictional force in opposite direction of motion. There is normal force perpendicular to the surface, and there is gravitational force straight down. Okay, there is a component, but those are not forces. Those are just the breaking down of the gravitational force. Okay, so let's go here. We have three forces acting on the object. So let's substitute here. We have the work done by the frictional force plus the work done by the normal force plus the work done by the gravitational force, and this is equal to half mass times final speed square minus half mass multiplied by the initial speed square. Okay, so this is what we have. Now, let's go separated just to understand better how to calculate the work done by the frictional force, the work done by the normal force, and the work done by the gravitational force. So let's begin with the work done by the frictional force. This is equal to frictional force multiplied by displacement multiplied by the cos of 180 degrees. Alright, now we don't have the frictional force, and because it was calculated in the previous video, we are not going to calculate it now. I'm just going to show you what it is. You can watch the previous video and this explains step by step how to calculate the frictional force. Same with the displacement. Okay, so here you will have to calculate the frictional force and the displacement. It was calculated in a previous video, so you can just follow the same steps. So for the frictional force, we are here. Frictional force is equal to kinetic coefficient of friction. Kinetic coefficient of friction multiplied by the normal. You don't have the normal, you have to use Newton's first law. That is how it is done. Then you substitute, and the frictional force is 38.53. Okay? Note, I'm not going to recalculate it now, but you must do it. You can watch the video. It is 38.53. So here it is 38. Sorry, let's keep using the blue. let's keep using the blue. It is 38,53 for the frictional force. 38, let me just go back quickly. 38,53. It was calculated. 38,53 multiplied by the displacement was also calculated previously. Note here there is the solution for the displacement. Note that the height is 2,5. You have the angle of inclination, and the displacement is this one here. So if you use the identities here, you have that sine of 35 is opposite side, which is height divided by the hypotenuse, which is the displacement. All right, you do the substitution and then you get 4,36. That would be the displacement from the bottom of the incline to the maximum height of the incline. All right, so 4,36. You can watch the previous video and I explain step by step. So it is 4,36. This is times cos of 180 degrees. This was also calculated in the previous video, but it's fine. So the answer for the work done of the frictional force is negative 167,99 joules. Remember, the meaning of the minus is the energy is being taken away from the system. Okay, now sorry, let's get the work done by the normal force. By the normal force is equal to normal force multiplied by the displacement multiplied by the cosine of theta. Okay, so now theta here is equal to 90 degrees. Note something, not always the angle between the displacement and the normal is going to be 90 degrees. It is not going to be always like that. We are eventually going to see example where it's not 90, but in this situation is 90. See here, this is 90 degrees, therefore the cosine of 90 is 0, and the work done by the normal force is also 0. So cos of 90 degrees is 0, therefore the work done by the normal force is equal to 0 joules. Okay? Fine. So let's look now to the work done by the gravitational force. Work done by the gravitational force will be equal to gravitational force multiplied by the displacement multiplied by the cosine of theta, the angle between the gravitational force and the displacement. So if you go back to the free body diagram, we can see that the angle, let me just change the color, try to get this red so you can see it properly. The angle will be all this one here. So this one here is 90, which is this small part, and then this one is 35. So it's 90 plus 35. Okay, that is the angle between the displacement and the gravitational force. 90 plus 35. Right, so let's substitute in here in the work done by the gravitational force. Let's go back to the previous color. So theta is equal to 90 plus 35 degree, which is equal to 125 degree. That is the angle between the gravitational force and the displacement. Okay, now if you substitute here, you have mass multiplied by acceleration due to gravity multiplied by the displacement multiplied by the cosine of 125 degree. You substitute, the mass is 60 multiplied by 9,8 multiplied by the displacement, which was calculated, is 4,36 multiplied by the cosine of 125 degree. So this one, let's use the bracket here. So it's 60 multiplied by 9,8. Let's use our calculator. It is 60 multiplied by 9,8 multiplied by 4,36 multiplied by the cos of 125 degree, and this is equal to minus 1470,47. So it is 1470,47 joules, also negative. Okay, so now we have the work done by each of the forces, and therefore let's substitute into the general equation for network. Let's rewrite the general equation for the network. This is equal to where net is the work done by the frictional force plus the work done by the normal force plus the work done by the gravitational force is equal to half mass final speed square minus half mass initial speed square. So if we substitute, the work done by the frictional force is right here, negative 166,99. So it is negative 167,99 plus 0, which is the normal, minus, let me make sure, yes, there we are, and then minus 1,470,47 is equal to half multiplied by 60, which is the mass, multiplied by final speed square, which is what we are looking for, minus half multiplied by 60 multiplied by 12 to the power 2, which is the initial speed of the object. Okay, and now we are here in just simple maths that you can actually do it in the calculator. I don't want to make this video very long because the work was done, and these calculations are quite simple. So you have to just add this one because both of them are negative, and then there you will get 1,600. This is 1,638,46, but you can check with your calculator, right? Negative because you keep the sign, then it's 30 multiplied by the final speed square minus, and this all this calculation here will give you 4,320. You can always check or recheck the calculation. When you solve this one is coming to the other side positive, so you will have minus 1,638,46 plus 4,320 equal to 30 multiplied by the final speed square. And when you solve this one, guys, which I'm not going to do it right now, the final speed will be equal to 9,45 meters per second. That is the answer using the work energy theorem. Thank you very much. You have the two options. Now, you may ask, why are we doing both options? All right. When you're writing an exam, sometimes the question asks you to use either one of the two options. It doesn't give you the option to select. For example, they may ask you in this question, they may say, find a final speed at the top using the work energy theorem, and therefore you are not allowed to use the first option. Or they may say, find the final speed at the top using the work energy theorem, the law of conservation of energy, and you are not allowed to use the work energy theorem. So it is useful to learn both options. Thank you very much. Next time we'll go to a new type of question. Okay, thanks a lot.